Hey, Brian. Happy
Hey,
Monday.
yeah, happy Monday.
Yeah, happy Monday. Happy Monday, everyone. And if you're watching later, well, happy whatever day it is. It ends in Y. It's one of those days. Let's do it, huh?
Yeah,
Hello, and welcome to Python Bytes, where we deliver Python news and headlines directly to your earbuds. This is episode 424, recorded March 17th, 2025. I'm Michael Kennedy.
and Brian Ocken.
And this episode is brought to you by us. Check out all of our things, courses at pythontests.com, talkpython.fm, all the places. If you want to get in touch with us, social media is probably the best place. I have a couple of things sent to me on social media. I don't know about you, Brian, but a couple that I'll be covering today.
Yeah,
So that's always fun. Find us on Blue Sky, find us on Mastodon. It doesn't matter. Doesn't matter what server you're on. Everyone talks to everyone on Mastodon. So you can find the links for all those at the top of the show. And we're refining and improving our newsletter format. It's getting better and better and more valuable, I think. It's got a nice little TLDR. Grab the links, grab the joke, and then dive into it if you want. And yeah, so Python Bytes.fm, smash that newsletter button and get signed up.
so,
I think people are getting a lot of value out of it. It's really nice, Brian.
yeah. I think it's great. Also, we've mentioned this before, but I really love the what you should know if we cover a topic that you're not quite don't quite understand what that topic's all about. You can check some of the background links in those. So that's cool.
Absolutely. I totally agree. And thank you to our Patreon supporters as well. Now, let us begin. Brian, with your first item. What you got for us?
I have weird quirk around rounding in Python, and actually this is just apparently normal. This is a feature, but I didn't know about it or I had forgotten about it. So we're linking to the weird quirk around rounding in Python, and the weird quirk is really just if your number ends in 0.5, like 1.5, 2.5, things like that. If you round it, it'll become even. It always goes even. So I didn't know this, but apparently it works better that way, and that's part of the IEEE standard 754. So 0.5 rounds to 0, 1.5 rounds to 2, and so forth and so on. Negative numbers also. So negative 1.5 will round to negative 2. Did you know this?
I did not know this. I do not accept this. I don't accept this as a mathematician, formerly, but by lots of training and education, I do not accept
So what do you?
that. You always round to even numbers.
So normally, like when it's been a long time since I've been in primary school, but isn't the like hand math thing that you round up if it's 0, like 1.5
You round,
plus to
it
2?
goes to the closest whole number.
Right,
That's
but
it.
at 0.5 there isn't a closest. It's right in the middle.
Ah, I see. So if it was 1.1.5000001,
It goes up. Yeah.
it goes up. I see. So it's basically deciding at the
Where does the
the
tie go?
decimal representation of the cutoff. So in my world, 4.99999 non-repeating but as many nines as you care to put goes down, and 0.5 and above goes up.
Huh?
If it's 1.4, you round down in regular math, right?
Yeah.
If it's 1.4999, you round down. If it's 1.4999999, as many as you want.
All the extra decimals don't matter. It's only with like the actual just if it's 0.5 zeros,
Yeah.
all zeros. So it's like
Yeah, yeah.
0.5, 1.5. That's a tie, then there is no closest integer. So where does it go? And I thought in math that we always just like half goes up.
Yeah, that's what I thought too.
But so it doesn't. It makes and there's reasons around it, because if you average, you want the average to be like, if you averaged a bunch of these, you want it to be 5. Like average, you have a bunch of random numbers, like 0 through 10 or 1 through 0. I don't know. You want it to be 5. But it's not. It's a little bit off. So this standard makes the average work. However, if you really want the normal way that we've been taught in grade school, there's a decimal feature that you can have it be round half up. So you can make it work normal, but apparently it's doing the right thing. You just didn't know that was the right thing. So anyway, it's a feature. It's also known as banker's rounding or Dutch rounding, apparently. That's learned something new there. And being that Guido is Dutch, maybe that has something. I don't know. Anyway, so just if you're rounding numbers, you should be aware of this. That's it, really. So,
yeah, you want an easy way to put it back to like grade school rounding? All you have to do is just say int of your number plus 0.5.
Int plus 0.5. Okay.
So if it's 1.5 plus 0.5, it's 2, and as a decimal, but then you turn it to an int, it's 2.
Right.
So it basically, yes, there's a truncate. Yeah, it truncates. The 0.5 is like, okay, bump it up. If it's 0.5 or above, bump it to the next number, then chop it off. Yeah.
Weird. I wonder why we do it different with. Yeah. Anyway.
I don't know. Interesting. Thanks, Tom, for the article and wild stuff.
Okay, what do you got for us?
Well, I've got some pretty interesting things here in terms of Python performance improvements. So, Brian, are you a fan of recursion?
Not really.
I'm not either, but I was against my will forced to take 2 programming courses in college. One was Fortran and one was Lisp. In Lisp or Scheme, it's all about recursion, right?
Yeah.
Like the way you do loops is to do recursion and so on. And in certain, not in Scheme, but in other languages, you can pretty quickly run out of stack space by doing recursion. And you might have gotten a Stack Overflow exception, and
that's
people
the name.
know about stack. That's the name. Like, what does this even mean? So there's ways to rewrite that at the runtime level to say the reason you run out of stack space is every function call gets its own new stack frame allocated and all of its locals and all that kind of stuff. What if we could just say reuse the existing stack space, grabbing some of the local variables that are being passed and just kind of reusing them, as long as you find a way to save the data to kind of go up the stack when you hit return or something like that, right?
Yeah.
And to my limited experience, that's what tail calls do. So if you've heard about doing tail recursion to make your recursion much faster, that's because not basically every single step in the loop, you don't have to recreate the function frame. So that's really good. And so the idea here, the news is that the Faster CPython project has added tail calls to Python. This is not exactly the same thing because it doesn't exactly have to do with recursion. It has to do with stepping through the bytecode instructions. Okay.
Okay.
So traditionally, there have been different ways in which Python does that. In the article from LWN.net says Python's many interpreters. So when you run a Python program, it converts it to bytecode. Yes, we know this. It says, however, there's actually a couple of ways in which this could be executed. There's the switch-based interpreter version, and then there's a go-to, what do they call it? The go-to, computed go-to statements version, okay? Which they say is a micro-op interpreter. So this is relatively new. Like you maybe have seen the giant switch statement, and by giant I mean 3,500 lines of C switch statement, single switch statement within a for loop that says for each, go to the next byte instruction, switch on what it is, do that, right? That has still stuck around because certain compilers don't support what's called a computed go-to statement or dynamic go-to statements, which sounds terrible, but it's a compiler level thing, not a human code level thing. Yeah. Like go-to statements are bad for people, but they're not necessarily bad for compilers. So the reason the old one is around is some of the compilers can't take it, but the new one's a little bit better. So the idea here is that I'm going to give credit to it. So Ken Jin, member of the Faster CPython project, has merged a new set of changes that have up to 10%, actually up to 40% performance improvements. On average, a geometric mean of 10% improvements, which is pretty awesome. So the idea is that we can change the way that computed goto based interpreter works using tail calls. So kind of like I described for recursion, it's reusing the stack frame as an optimization. So modern compilers like Clang and GCC can do tail call optimizations opportunistically, but until recently they weren't 100% guaranteed. Like some compilers have that level like -01, 02. Like you put it up too high and stuff starts to break. You're like, that's weird. You think that would just work, but right. And I think that's kind of the case is here. And apparently it's more stable, so they can rely on it. So basically, there's this new interpreter, and as the article points out, like it might seem crazy to add a third interpreter to Python, and it seems like a lot of work, right?
Yeah.
But if you go down to the bottom, it says somewhere that Jin's change is only about 200 lines of Python code, which generates the interpreter and generates the code for the tail calling version. So it's actually not very much effort at all. So what it does is it'll say, like, does your compiler support this faster version of behaviors? If it does, we'll give you a faster Python. I think that's pretty awesome.
Yeah. Yeah. I think.
Yeah, I think so.
If it works.
And as long as it works. And so this is already merged into Python 3.14, which is pretty excellent. And it does say, look, if you're on an older build of Python, or you're building Python yourself with an old compiler, you're going to get the slow version. Like, okay, if you care about faster Python, compile it with modern compilers, or download one with a binary. Like, I bet you UV is already on top of this. You know what I mean? So
3.14 already has this in it?
That's what it says.
Okay, cool.
It says merged. Jin's work has been merged and should be available to end users in Python 3.14, expected Halloween 2025. But what's really interesting here is Jin measured the performance impact of the change as a 10% on average, but up to 40% on some benchmark speed improvement, and then framed it this way, which I thought was really interesting. The speed up is roughly equal to 2 CPython releases worth of improvements. So like 3.11 to 3.13 in this just 200 lines of Python code, which is amazing. For example, cool. CPython 3.12 roughly sped up by 5%. So, year over year sort of thing. So just this one change in 3.14 is going to be pretty mega. It's awesome.
Yeah. Yeah, no, this is really cool. I'm just when I first heard about this, I was excited that maybe we get tail recursion optimization in Python, but we don't. So.
I'm okay without it. It would be good to have, but let's not encourage them. No, I use recursion sometimes. Look, if you've got hierarchical data structures, recursion is magical, right? It's like it exactly matches what you do with that hierarchy as you kind of traverse it.
But in life, though, I think I've only used recursion and tail optimization in college. So, but I don't do because I don't do recursive sort of things very much. But that's all right.
Yeah. Andrew out there points out, I was overly excited to see this when I first saw these headlines, thinking Python itself was getting tail call optimization.
Yeah.
Very nice, nonetheless. Going to motivate me to get Clang builds working with the required options. Yeah, absolutely cool. Like I said, I hope the UV folks are on this, because UV, VE, and V, and we just get 10% faster. Like, let's go. I'm here for it.
Yeah, and I think that because of UV, we're getting more people trying new versions of Python faster, because all you have to do is create a virtual environment and pick it, and you get it.
Python 3.14b or whatever it is, however you specify it.
Yeah. So
absolutely.
Anyway.
All right, back to you.
Okay. Well, let's see. We've got something from Rodrigo, and I'm anyway, Rodrigo from Maths PP. Maths. Okay. I'm gonna have to work on this one, but he puts out a lot of great stuff. He's writing about Python and very active on Blue Sky, and I think I don't maybe somehow I missed this. This is he's using translate and make trans together. He said, uh, don't use the method replace to remove punctuation from a Python string. Use translate instead. It's much more efficient and more general. And his example, which I had to like parse a little bit to figure this out. So basically, like his example of "Hello World" with a comma and a exclamation point, we want to strip that all the punctuation out. How do you do that? Well, you can use make trans, which is translates from one string, like a some things in a string, to another set of characters in a string. It's kind of a weird function, but he's giving it nothing. So the translate from and to are empty. But he's also giving the third parameter is stuff to just strip out. And the way make trans does that is it takes all of the characters in the third argument and replaces them with none, and those that end up getting removed. And for the third character, he's using string dot punctuation. So he's creating a translation table that all it does is remove punctuation, and that's what we want. Passing it to trans, and you get a string. And it still seems like maybe there should be an easier way in Python to do this, but that's pretty cool. I like it. So he also has an article that talks about not exactly this thing, but he's got an article about string translate and make trans methods if you want to dive deeper into those, or you can just use this little trick. So
Very interesting. News to me. It's a little bit like when I learned that strip, if I have like str, if I want to take str off of the word string and just leave ing,
yeah,
right? If you say L strip and you put the string str in there, I always thought it would find that string and take it out. But no, that just takes the S's and the T's and the R's. So RTS would also be right. So there's remove prefix and remove suffix and stuff like that. And this one's a little bit like that. Like, I didn't quite do what I thought, but apparently there's another way.
Yeah. And one of the interesting things about make trans that always throws me is it's an ordering thing. So you go like from and to, and it utilizes the fact that strings are iterable, and that's not something I normally think about unless I guess when I'm parsing stuff, when I'm parsing a file or parsing a line, I utilize the fact that they're iterable. But normally I don't iterate it over characters of a string. That's it seems like maybe that's too easy to get wrong. But anyway.
Yeah, perhaps.
All right. What you got for us next? Oh, we're done.
Well, I got extra.
Lots of extras. Yay, because we had some short topics. So let's get
so let's get some extras. So first of all, this was sent in by several people, including Owen Lamont. Thank you for that. And this is a 9-minute video of animation versus coding, and it's the weirdest. I don't even know what to make of it. It's an insane amount of work that these people put into it. I'll just play a little bit of it as we're talking, Brian. And so the idea here is it's like an animation of somebody writing code and seeing how it kind of interacts. And then the computer kind of comes alive, and there's a battle with the computer. The computer will like fire up Turtle and all sorts of stuff. And it ends up in the end like creating AIs that are running around and doing all sorts of stuff. And I think, spoiler, I think the person character wins by like controlling the computer with AI. I'm not entirely sure of the outcome. I totally forget, but it features Pygame, Pandas, PyTorch. I mean, it's nuts. So anyway, if you're looking for some entertainment, that's worth checking out.
I gotta watch that. It's a 10-minute video though.
Yeah. If you're eating lunch or something, you're like, I need a little break from programming. Let me watch a video about programming. I can do that.
Yeah.
All right. Next up in the news, I brought this up more as a parallel, as a other places are doing this too, right? So one of the concerns and benefits of a lot of these new tools is they are written in Rust for Python, right? So why is UV fast? Mostly algorithms, but also Rust. Why is Rust fast? Mostly Rust, probably also algorithms. You know what I mean? Like things like that, right? Why are we running our website on Granian? Rust, Hyper, all those sorts of things. So the folks over at TypeScript, Anders Hallsberg, the creator of it, and the Microsoft team, just made TypeScript, which is a typed JavaScript thing. And I believe the runtime behind it as well. I think there's some kind of runtime. I haven't done much with TypeScript that way, but certainly like its compiler and its language LSP for editors and stuff like that, 10 times faster by rewriting it in Go.
Oh, geez.
So that's interesting. And they said, look, we tried a bunch of different languages. We tried Rust, we tried C, we tried Go, we tried, I think, Zig even. They mentioned a lot of languages. And he said, look, Go allows us to align the memory stuff in as you do in native languages, like align the memory structures exactly right for the compiler and stuff like that or something. So anyway, like I know a lot of people listening also do JavaScript and TypeScript stuff, and I think it's, here's another 10-minute video to watch that's kind of interesting. 13 minutes technically, but
so that's
you can
like
drop the last.
Everything that uses TypeScript would be faster then, or?
So that's what I'm not. There is some kind of runtime that they're doing something with that they rewrote. Like TypeScript used to compile itself with TypeScript, but there's also something that runs that does the language server. I feel it's a little like Node, but like I said, I'm far out over my skis at this point. I think when you talk about stuff that runs it, mostly that's in the browser, and then that's going to be just the JavaScript engine, because the now Go-based compiler will compile the JavaScript and then it's run natively. Anyway, pretty interesting. I thought it was worth throwing out there because it's like, oh, Python's getting overrun by Rust. What in the world's going on? And like, this is a trend of more places, not just Python. That's what I kind of wanted to point out here.
Yeah.
They made different choices for different reasons, but it's still pretty interesting. Okay. Thanks for showing me that, YouTube. All right. This next section I entitled Firefox Lies. So, Brian, it's very exciting. This weekend was the first Formula One race of the year, and they're going to have something like 23 more. Very good. And it was amazing. If you haven't watched it, I won't spoil it, but it was one of the best Formula One races I've watched in a very long time. It was full of drama, full of interesting things. It was good.
And this...
So what does this have to do with Firefox?
Yeah.
So I tried to watch it. I subscribed to F1 TV so that I can watch all the races, all the replays, all the qualifyings, all that kind of stuff. Instead of getting cable, which is a complete ripoff, paying $200 a month, I paid like $80 once, and now I watch all those with replays and whatever, right? I tried to watch that with Firefox. Do you know what it said? Your browser is out of date and unsupported. You cannot watch this website. You must go away because you don't have Chrome, basically. And I said, I seriously doubt it. I seriously doubt that Firefox won't work. F1, I said. And I said, no, we're doing it. We're watching it in Firefox because I have all this blocking turned on in my other favorite browser, Vivaldi. Right? And I don't want to turn off the blocking and stuff. So I have like kind of my bare Firefox is the one that allows all the badness through so I can watch stuff that, Peacock and F1 and so on. So when they say you can't watch it, I'm like, no, I can watch it. So what I did is I put I'll link to how you do this, but I just went up and just told Firefox its user agent is the latest version of Chrome. Hence, Firefox lies. I went back to F1 TV. Welcome. Which replay would you like to watch? Boom, perfect. Played perfectly. There's nothing wrong with Firefox. The people are just too lazy to test against it. And so they're like, well, you got to have Chrome. Like, all right, fine, I have Chrome. Oh, look, it works. This is the same reason that Vivaldi works. Vivaldi, you cannot know like the market share of Vivaldi per user agent, like some of those sites that track user agent frequency and stuff.
Yeah,
because they just say the same thing. They just say my user agent is the latest version of Chrome so that it works. Because if everybody had to also say, we also support Vivaldi, it would say crap like that all the time.
Yeah.
And so if you love Firefox or any other browser really, but I have the instructions for Firefox and you run into those problems, just make it lie. I'm really loving Zen. We talked about that a few times, and I'm considering making my Zen claim to be the latest latest Chrome as well.
Yeah. That's one of the reasons why I like Vivaldi as well, because especially in corporations, a lot of internal tools, they don't want to, I mean, that's a lot of work for internal tools to test everything. So they just usually test against Chrome. And so with Vivaldi, I can just use internal tools just fine. So
yeah, it's indistinguishable. It doesn't know. And that's why wouldn't it be? It's literally the same embedded engine in the terms of Vivaldi. It literally is Chrome. It just doesn't have all this scumbaggery to it.
Yeah.
Yeah. All right. This extra is getting long. I'll go quick. All right. Startup Row. Startup Row applications are open. Does your startup qualify for Startup Row? Here's some criteria. Use Python. Your startup is less than 2.5 years old. You have less than fewer than 25 employees, et cetera, et cetera. You will come to the conference and so on. This is a really cool program. And if you have a startup and you want to get some awareness, consider applying to this. Right.
So this is at PyCon on Sundays. There's they take away all of the booths and everything like that, and then we have a couple of rows of startups that you can.
Yes, I think it even might be Thursday through Saturday. I think it might be during the expo.
During
last
the expo.
year, it was in a corner. It was in a corner, but it was. I think it was during the expo.
Oh right, yeah,
but, yeah. You basically get a booth as like a $10,000 equivalent booth. As if you were another advertiser there, but it's to promote your Python-based startup. So people should check that out. I actually did an interview 2 years ago, coming up on 2 years ago, called a Stroll Down Startup Lane, where I went and interviewed all the people, all the different startups, like 10 minutes per startup or something like that.
Nice.
Yeah.
Cool.
Whew, last of the extras. I am publishing a book, Brian.
Wow. Neat.
Thanks. Talk Python in production. So the subtitle is A Cloud Agnostic Guide to Building, Scaling, and Managing Your Own Python Infrastructure. So I've talked a lot about different ways we're doing different things with infrastructure, but here's a book. It's about 250 pages that goes into all the details of like how you can run efficient, high performance, but not complex, not expensive Python infrastructure. And you can read about the first third of it online. And it says buy the book, but you can't quite buy the book. Just today, I'm still trying to get it all ready to go. So right now you can subscribe to get notified when you can buy the book. And in a week or two, you will be able to buy the book at Amazon and probably Gumroad is what I'm thinking.
Okay. I like Gumroad.
Yeah. Anyway, so the link to that is in the show notes. And hopefully people will check that out.
Cool.
Yeah. All right. That's it for my extras. You got any extras?
No, I wanted to announce the changes to the course, but I'm still working on it. Life getting in the way. So
yeah, I hear it. Well, until then, people don't necessarily have to test, right? They don't need work on your testing course.
Yes, they do. Yeah.
No, they can just test in production. So the joke is a Star Trek one. This comes to us by Greg Matiola. Thank you. It says, as Goran says, we will test in production and die with glorious honor. And it's got like a cool little meme over a Star Trek Klingon character. It's beautiful.
Yeah. But it's usually your customers that will die in glorious honor. So.
They die first, and then you wither.
Yeah. Okay. Yeah.
So what I'm hearing is you're saying you don't actually support this advice.
I don't, but okay. But there is a certain car company that seems to have pieces of their cars flying off I think.
Does it look a little like a spaceship?
Yeah, it does. And apparently they just glued some of the stuff onto the side as some of this. Anyway.
I was in Nashville with my kids the last summer, and we were driving along in our rental car, which was not one of these spaceshipy things. There was apparently the thing that goes along the column has like a fancy cover, like a bodywork.
Yeah.
The columns that hold up the roof and along the windshield, and it just peeled back, ripped off, and started whacking against the car on the highway. And so this was on our way to the airport. So one of my kids had to reach out and hold the bodywork in place for about 15 minutes, and she was kind of done holding the bodywork in place when we got to the airport.
That's crazy.
So bad.
Yeah. Did you get charged for the damage to the car?
No, I kind of like mushed it back. I said, "How's the car?" It was fine. That piece is a little bit loose. You might want to check it. Bye.
Bye. Yeah.
No, it was okay.
Anyway,
yeah. Test in production.
Test in production. No, don't test in production. Test before production.
Absolutely.
Yeah.
But do listen to this show every week. We'll be back next Monday at 10, probably, most likely.
Tell your friends.
Until then, thank you, everyone. And if you're watching this on YouTube, go ahead and subscribe on YouTube as well. You'll get notifications. Bye.
Bye.